Yo, 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 everybody. Hello. Hope everyone's doing well. We're going to talk about standard form. So, this is part one. We will have a part two later on, but part one is priority right now. So, if you've not watched 2.1 or 2.2, you have to know that information for this video because we're going to talk about a different form for graphing lines. And so, but we still need to know the basics of graphing a line and what a y-intercept is and so on. So make sure you watch that first, please. So make sure 2.1 first. So standard form. Whoa, that was like a crooked A there. Sorry. Okay, so standard form is AX plus BY equals C. Now, the X and the Y still represent an ordered pair on the line. So X and Y are still for an ordered pair, and they're still going to stay as X and Y whenever we actually write the equation. The A, the B, and the C, they don't actually represent really anything. Okay, this is just what standard form equations are going to look like. So you might have something like 3x plus 4y equals 12. This would be an equation in standard form. Now, what we do is when we use standard form, we can graph lines from this format without having to change it to slope-intercept form. And we do that by graphing the intercepts. And I'm going to show you guys how on the next slide. But this is standard form. AX plus BY equals C. And this is an example of what that looks like. Okay. So here's what we do. So here I have an equation in standard form. 3x minus 2y equals 9. So what we do when graphing in a form that looks like this, because I still have an x and a y, so it's still a linear equation. There's still x, there's still y. That means that this is still going to graph a line. So what I'm going to do is I'm going to graph by using the intercepts. So here's what I mean by the intercepts. By definition, when we talked about the y-intercept, whenever a line crosses the y-axis, that's the y-intercept. Okay? Let's talk about what every single x value is on this line at the y-axis. Well, the x is 0 on all of these points here. X is 0, x is 0, x is 0. Everywhere on the y-axis, x is equal to 0. So by definition, the y-intercept is always when x is 0. And then it's whatever the y is. So knowing that information, what I can do is one cool thing about linear equations. If I know that, if I want to know what my y coordinate is whenever x is 0, I can actually plug in 0 for x right here. So when I do that, I plug in 0 for x right here. I have 3 times 0 minus 2y equals 9. So because x and y represent any ordered pair that's on the line, if this is the equation of the line, I can figure out what is a point when x is 0. I can just plug in x is 0. It's almost like having this is my rule, and I can plug in an input-output, make an input-output table, plug in 0 for x, and figure out what my y is by substituting it in. And then I would just solve the equation. Well, then the reason why it's nice to do this with zeros is because 3 times 0 is 0. That really makes this just go away because there's no point in writing 0 minus something because has no relevance to it. So I just have the equation of negative 2y equals 9. Well, since my equation is negative 2y equals 9, I needed to solve for y by dividing by negative 2. And I got y equals negative 4.5 or 4.5 or 9 over 2. But my y-intercept is y equals negative 4.5. I did a decimal because I want to know where to graph this exactly on the line, right? I want to know exactly where is this so that I can have an accurate graph here. So my y-intercept is at negative 4.5, which is 4.5, which is right here. Now, that's the y-intercept. So I have 1 point. I still don't even know the slope of this line. So what I've done is I figured out what my y-intercept is. When x is 0, my y is negative 4.5. Well, what I can also do is I can do the same thing for when y is 0. Because whenever y is 0, that's this axis right here. That's the x-axis. So whenever y is 0, that's going to give me the x-intercept. That's going to tell me when does this line cross the x-axis. So now I can figure out, okay, well, what's my x value when y is 0? So I can plug in 0 for y here. And then I can solve my equation. 3x minus 2 times 0 equals 9. Well, 2 times 0 is just 0, so that all goes away. So I just get 3x equals 9, which means x equals 3. So the x-intercept is at 3, 0. There's my x-intercept. Now I have 2 points. I have a y-intercept. I have an x-intercept. That means I can graph the line. And it should look something like that. I could even actually count the slope if I wanted to. The problem is this half makes it very difficult, but it goes up 4.5 over 3. So the slope could be 4.5 over 3, which is really 9 over 6. So I would multiply that by 2 to get rid of the decimal. But I don't even need to know the slope. All I know is I was able to graph a line by plugging in 0 for x, figuring out what my y value is, plugging in 0 for y, figuring out what my x value is. And that gives me the x-intercept and the y-intercept. Okay. Now, sometimes in standard form, you won't have an x or a y. Because maybe this value right here would be equal to 0, and anything times 0 is just 0, and it just goes away. So sometimes the actual equation itself will look just like this, like 2y equals 6. So if I solve for y, I can divide by 2. I get an equation of just y equals 3. Well, this was the whole graph. This was my whole equation. So whenever I have an equation that is just y equals something, so y equals 3. Well, y equals 3 is right here on a coordinate plane, right? There's y equals 3. But y equals 3, that is true for everything right here where y is 3. That's supposed to be a straight line on 3. So for the equation y equals 3, I have a flat line with the slope of 0 at y is equal to 3, because right here, y is still 3. This point, I don't know what the x value is, but I know my y is 3. This point here, I don't know what my x value is, but I know my y is 3. Every point on this line, y is equal to 3. So for y equals 3, I have a horizontal line that goes through 3. If you have a equation in standard form that doesn't have a y, but now it has an x, so this means the b is 0. Well, if I divide these by 3, I have x equals -2. So if I were to graph this, well, -2 is at 1, 2. This is x is -2, is right here. X is -2. Well, x is -2 would be a vertical line. A vertical line that goes through -2. This has an undefined slope, because undefined is when we have a vertical line. But every single point on this line is x is equal to -2. I don't know what my y is, but it doesn't matter, because x is -2 on every single point. So that's why this is the equation for x is equal to -2. This is the graph for the equation that is x is equal to -2. So whenever I have x equals a number, it's always a vertical line going through whatever that value is on x. Whenever I have y equals a value, it's always a horizontal line going through the value at y. So we'll do this first one together, and then I want you guys to try the second one on your own. So first, I want to graph the line that represents each linear equation. So this is in standard form. Now, there is not a number here in front of y. That means that there's just a 1. That's -5x plus 1y. So if I wanted to graph in standard form by graphing by using the intercepts, I could do that by plugging in my 2 points. I could figure out, well, what is, when x is 0, what's my y? And then I could also figure out, well, when y is 0, what is my x? That's going to give me my x-intercept. This is going to give me my y-intercept. So I actually have to do the math to figure that out. So if I plug in 0 for x, I have y equals -10. Oh, that goes away. There's my x-intercept. There's my y-intercept. My y-intercept is at -10. So that's the point 0, -10. If I were to plug in 0 for y, that'd be -5x equals -10. Because if I plug in 0 for y, that's just plus 0. Well, again, that just goes away, which is why I'm left here. We'll divide by -5. I get x equals 2. So my x-intercept is at 2, 0. So now I can create my coordinate plane and I can make a graph. Now I have to go I need my y to be down 10. Well, let's see how many I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could go down by ones. And sometimes if you guys need to, you can also count by twos if you need to. And that's fine. If you do count by twos, you just need to show that you're counting by twos. But I'm not even going to worry about doing that right now because I don't need to. I'm going to make my graph like so. I'll adjust those a little bit. So what I did, oops, oh, that worked out. I'll move like this. So this is my 4 quadrants. Okay, there's my origin at 0, 0. And now I can plot my point, my intercept. 0, negative 10 is at 1, 2, 3, 4, 5, 6, 7, 8, 9. I still didn't go far enough, but there's 10. And then 0, 2, 1, 2. So there's my line. There's my 2 points. Weep. Right there. So I was just able to graph by using the intercepts. Okay? Go ahead and try the second one on your own. See how you do. Graph it. Find the x and y intercept. So pause it, graph it, go. Okay? So if I plug in x as 0, that goes away. So then my y is just divided by negative 6. That negative follows the number. That goes away. I'm left with y equals negative 2. So that's where negative 2 goes. So there's my y-intercept. It's at negative 2. Now I'm going to do the same process. But now it's when x is when y is 0. Because that's going to give me my x-intercept. That makes it go away. So I just got to divide by negative 3. And I get x equals negative 4. So that gives me my x-intercept at negative 4, 0. Now, those are pretty easy numbers to work with. I can just make a normal coordinate plane here. I got to move it around just a little bit. There we go. That's good enough. And then now I'm going to plot my point 0, negative 2. Do that in blue here. There's my y-intercept. And then my x-intercept's at negative 4. 1, 2, 3, 4. And then now I can make my line. And there we have it. Okay. Now, try these two. These ones are the special circumstances, so see how you do on this one. So pause it, try both of them, and then unpause and see how you did. Okay, so here should have been your 2 graphs. I divided by 5 on both sides over here, got x equals 3. Well, that's a vertical line right here at 3 with an undefined slope. Divided both sides by negative 4, y equals negative 5. Well, y is negative 5 is right down here. That's a horizontal line with a 0 slope. And that's all for those guys. Okay, so sometimes you won't even be asked to graph. You'll just be asked, well, what points represent the x and y intercepts of each equation when they are in standard form? So when that's the case, it's again pretty much doing what we just did by graphing from standard form, but you're finding the intercept, so you're just listing the points instead. So what I would do is, again, I would plug in 0 for x, figure out what my y is, plug in 0 for y, figure out what my x is, and this is going to give me my x-intercept, and this is going to give me my y-intercept. And then I would just label those and write those down. So when I plug in 0 for x, this goes away. I have negative 5y equals 80. So I can just divide by negative 5. And that's going to give me negative 16. So the y-intercept is 0, negative 16. This is the full point. So make sure if you ask for a coordinate or an ordered pair for the y-intercept, you write out the whole ordered pair. Don't just tell me y equals negative 16. Do the same thing for when y is 0, so that makes the y go away. I just get 4x equals 80, which means x equals 20. So the x-intercept is at 20, 0. Those are my points. Go ahead and pause and answer numbers 8 and 9. Okay, so those are your answers. So for number 8, your x-intercept was 16, 0. The y-intercept was 0, 14. The x-intercept, I just plugged in 0 for y, which made that go away. 112 divided by 7 is 16. And then for my y-intercept, I just plugged in 0 for 7x, which makes that go away. So divided by 8, 112 divided by 8 is 14. And then same thing over here, 18, 0, 0, negative 12. Okay, guys, that is it. If you guys have any questions, please do not hesitate to ask. There's your things to remember. There's your independent practice. Get it done. Thank you for watching. Gradius out.